Hello?
Lay, you're the only one.
Oh,
Yeah. Unless you have, I'm going to be here. If you like, here's what I would propose, right? Just work on any project you like using linked list in C++, right? And I'm just happy to be around. If you get stuck, you can ask me, or if you want me to watch while you're coding, I'm happy to watch while you're coding until someone joins. Yeah. You can do whatever you want, except quests. Okay, don't work on your quests. But just yeah. Okay, so pick up some random, pick up an editor, start coding some linked nodes, and maybe create a structure of your own. One node with 15 pointers, whatever it is, right? You just want to play around. You don't have to do anything in particular, right? See what happens if you create a class with 15 pointers in it, 100 pointers, a vector of pointers, right? And draw it out on a piece of paper and say, hey, I got it on a piece of paper. Can I replicate it in code?
okay.
Right?
Could I ask a question about a quest?
You can totally do that. Yeah. Oh, about the quests itself? Yeah, sure.
Yeah.
Meta
So
question, sure.
Quest 9, and I couldn't get past the third advanced point,
Right.
advanced current.
Mhm.
And when it shows me the differences between the solution and my list or stack, it cuts off my stack before it shows me where my current is at.
I'm sorry, when it shows your list and the reference list, you mean?
Right. It cuts
Yeah.
off the it cuts off my list before it shows me where my current.
Yeah. That's to be expected.
Yeah.
I'm pretty sure when it prints the two lists, I say something like your list using my toString.
Uh-huh.
Yeah.
Okay.
So yeah. I make sure I cut things off. I think only the information that is relevant to you would be presented, and the rest would be truncated. Most of the time, that works, right? Sometimes your error is beyond what can be displayed. That way, then you have to resort to snooping like Sherlock Holmes to find out what's going on in your code. But most of the time, you can just look at the two outputs, and if it says your list is different from mine, there is something that is definitely different. Okay, either in what is shown, or if I'm only able to show like 200 lines and your error is at the tail of the list, like 1,000 lines down, I won't be able to show it, right?
Right.
So then you can assume that, okay, well, the error is something that happened beyond what was able to be shown.
Okay.
That itself is very useful information. So
Okay.
it's about, it must be to do with the tail or previous to current, which is somewhere there. Something like that.
Okay.
So then you can try and replicate what might have gone on in your own test situation. Write a 10-line list and use your methods and see what goes on and things like that.
Okay. How is the list constructed for that test? Is it made with all add
I don't know. You got. I don't know. I think the truth is I've forgotten how I've done that. It's quite a long time, but it doesn't matter. You shouldn't need to know.
Okay.
You just need to create the list that is on the spec.
Mm-hmm.
Yeah.
Okay. And yeah, that's all right.
Yeah. In fact, I don't know how. In fact, it's such a long time that I've forgotten how I put the reference list together. Did I do it node by node, or did I use a method? I've actually forgotten now.
Okay.
But yeah, thankfully we don't have to remember these things, right? Because we have it in the spec. We know that's what we're constructing. Yes.
Yeah.
Those yellow and orange and green boxes, that's what we're constructing.
Right.
So as long as that is there in memory, you'll see that whatever I do for making the reference list, they should be the same, or if they're right.
Okay. I got it.
I think in 2B, later on in 2B, you'll be making graphs, right? And graphs are very big structures, lots and lots of pointers. Like, yes, graphs will they'll look very funky on, already you have loops and, many, and each node may have many branches and so on. So it looks very messy on paper. So not all graphs, especially big ones, can be shown on screen. So in such situations, what I'll do is, if there's a big graph that you have to create, I'll just say, well, you know, he's Lay's made a graph and it's there in memory, and I've got my reference graph, which I've got here. They may be huge structures, like, you know, San Francisco and, you know, San Francisco or something like that. So I can't look at, yeah, I won't look at, you know, do they look exactly identical? I'll just see if they're identical in virtual space, meaning I start at the same node, all right? And then I go right here and right there also.
Okay.
Do I end up in the same place? Do I go left? You know, is it basically, if I do the exact same moves, I should end up in the exact same places.
Okay.
Yeah.
Okay.
Same thing for lists, same thing for trees. Yeah. Everything, it'll, you know, if everything you try, if you use that technique, saying it doesn't have to look the same, it just has to behave the same as far as the API is concerned. Then you can build massively scalable big systems also.
Okay. All right.
Cool. Yeah, like I was said, Hiram's also here now. Hi, Hiram. I saw you logged in before. Just, you know, 1 second before I logged in, you logged in, but when I logged in, you weren't there.
I got the wrong link. I clicked the wrong link in the calendar, and so
No, I'm saying you. I got an email saying Hiram already joined the meeting, right?
That's
but
really
from
weird.
Zoom, and then I logged in, and then you weren't there. I was the only one.
Yeah, so I clicked the wrong link. I'm pretty sure because on my calendar there's like the lecture, and then there's the class, and then there's the class again, right?
Wow.
It's really weird. So I always have to remember to click only the lecture one.
Oh,
But
that's so funny. So you have three links like that.
I have 3 links like that. Yeah. So I clicked the wrong link, and it put me in a meeting, and then I waited there until 8:15 because I was like, what if no one's here? And then I came here.
Oh, I see. Okay, well, I think something funky happened there. But
Yeah,
anyway, I'm
something
glad
like
you're back. I'm glad you're back.
Yeah.
Yeah, I hope you guys had a good break. But you know, Thanksgiving break is for students mostly just preparing for the final. Yes, because yeah, I know. Lots of students I know. They came home for Thanksgiving, but really they're not partying or you know, having a fun time. They're all just cramming. Not cramming in a bad way, but they're actually working through. This is the computer science students I know, and I'm not talking about Foothill students, right? Even students from other UCs and other places, they've come home for, especially in my neighborhood, right? So come home for Christmas, and my kids too, for the Thanksgiving break. And when you know, I remember when I was in college. Was it in college? Yeah, or maybe when after I started working. Yeah, Thanksgiving break used to be a real break, but now Thanksgiving break for students, anyway, I find is really, you know, working time, which is cool, which is really cool. Because you get a big break after the final on December 9. 2.5 weeks of pretty much you don't have to do anything. But I'd say you should be coding then, right? I don't know how many of you are planning to do my 2B, but if you are, I'd say just make headway in the green quests over the winter break, right? And complete at least the first 3 or 4 quests. You'll be like in great shape if you enroll in 2B after that. I'm around, happy to answer questions. Not just now, even during the winter break, right? And if you have an interesting project that is, you know, a project that involves C++, or maybe even doesn't involve C++, maybe it's an app you're putting together and you need my you know, help or something, I'm happy to hop on a Zoom call sometime, yeah, and help out if possible, brainstorm with you, or suggest ways in which you can put your project together. All of that I'm happy to do. Right? I'm already helping a few other people, so it's not a big deal for me. Yeah, so here's what I was suggesting to Lay before you guys came around. It's basically today we're supposed to be doing linked lists. Yes, I'm happy for us to basically code up a linked list without a head pointer, right? And without actually creating a linked list class, right? We have to be careful because the class is what you're going to be doing for the quest. We'll just play with the raw inside of the linked list, like we did for stacks. We'll just create a node and then link a lot of nodes to it, and then say, okay, now from this node, I want to, find all these things. We can do all those fun things. It will actually encroach on a lot of things that you have to do in Quest 9. So I'm kind of reluctant to do that. However, if you really, really want, we can do that. Or you guys can do that and I can watch. That's what I was telling Lei. Yes. So one of you or two of you, or all of you can pick up a screen or update window, start coding up anything you want. It doesn't even have to be a linked list, okay? But it has to have pointers and indirection. Basically, linked list is the simplest of those. That's why I suggested linked list, right? So, so you can have a node with a vector of pointers, basically spray painting links all over, right? Like a star, right? Bam, 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 bam. So you can do all of that. You can play around whatever you want, okay? And then you can have constructors and destructors. You can also see if memory, and then you can ask me, right? We created a special class with 15 pointers. Here's the constructor and destructor we created. Do you think there's any memory leak, right? What do you think we should do, right? How can we tackle this? How can we handle the situation? And things like that. I'm happy to answer it. Even if you have complex data structures, I can handle it, but if I can answer it. But I think if you restrict your questions to linked list, it may help you right now for 2A. But no means, that doesn't mean you have to restrict your questions to this, right? Even if you have a graph-like data structure with many pointers, or a trie in which, a trie is it's called a, prefix tree, right? You'll actually implement that in CS2B, right? Is a data structure in which it's coded in a intuitively opposite way than how we normally code data structures, right? It's basically, if you have a graph, right? So when you talk about graphs later on, right? Maybe when you're working, graphs can be stored in two different ways, right? One way is you have a node, right? You finite state machines. Most of you doing computer science, you have finite state machines, right? I don't know. So a finite state machine is basically a computer, meaning I don't need a human behind it. Here's a state. Something happens to that state, it's going to go to a completely different state. Yes. There's no in between. Like there's not a continuum. It's basically discrete states. So you're here, something happens, and you don't move like a dx, but you actually move one unit, bam, like that. So it's basically like a graph paper in which you only have the grid points, lattice points, right? You can't go travel on the continuum, but you can hop from dot to dot. Does it make sense? Yeah. So that is basically a discrete machine, isn't it? Because a continuous machine is like a car with wheels. It can basically roll on the continuum. It can exist in any real numbered value on the x-axis. It can be there. Yes. But I'm saying no. I've invented a new machine, right? Right, which does not, which has spokes. No, which has these grid, gear-like things, right? It cannot stay any place, but it can hop from one place to another, right? It can do these quantum jumps from one universe to another, bam, 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 but it can't go between, right? Maybe you invented a machine like that. So that's a finite state machine, because it can only exist in a countable, discrete number of states. It cannot exist anywhere. It doesn't make sense. It's a very nice point, and it's a very subtle point. And it is probably something that, when you study computer science and, graduate from CS2C and go on to study theoretical computer science, maybe at a UC or something, this is something that a professor is going to drill into you, right? Maybe they'll spend like 5 lectures trying to get that point embedded, that there is something called a finite state machine, which is basically just a Turing machine, right? This is just an abstraction of a Turing machine, a higher level of a Turing machine, right? It can exist in one of multiple states, but they're all finite and countable. So that is a finite state machine. So the beauty of a finite state machine is that it's computationally tractable using a lot of algorithms, right? Because if it's continuous space, you need a mathematical model, density distributions. But finite state machine, there are a number of graphical algorithms, right? You can use to model what's going to happen. And where are we going with finite state machines, right? Yeah. All right. So maybe you say. Why did I start talking about finite? Yeah, you're going to learn this in some course. Machines, we're talking about regular expressions. I wanted to talk about we started talking about linked lists. Can someone explain? Help me remember why we started talking about finite state machines at all. Geez.
It was something to do with the opposite of how you'd expect to create a data structure.
Yes, thank you so much. Thank you, Hiram. Yeah, I say incredible, isn't it? And I would never have it would have taken me maybe 10 minutes to come to what Hiram said. So a trie, a prefix tree, is intuitively opposite, because in a graph, you say in a finite state machine, that's why, right? You're going to say, here is a graph. I'm going to say that every time you jump from this state to that state, it's going to emit a symbol. So if I have a string, right, A, B, C, D, E, I can say start with node 0, nothing there, right? Jump to node 1. But in the process of jumping to node 1, you're going to emit A. In the process of jumping from 1 to 2, you're going to emit B. Right? So anyone who jumps from 1 to 2 is going to emit a B and then jump. So say an electron jumping from shell to shell and emits a photon, right? Discrete states. So like that, a finite state machine is basically, you can code it in such a way that some action happens when the jump happens. Action happens when the jump happens, right? So that is a finite state machine, yes or no? Okay, now there is an analog. Someone came along and said, okay, well, you know what? I can do an exactly equivalent representation, but I don't have to code the action on the jump, right? Think about it. It's beautiful, isn't it? I hope all of this helps you, right? Maybe some of you are already in UCs, right? And you're studying about finite state machines. Because I know my daughter is studying about finite state machines right now, right? So, and she's probably in one of the classes like you, right? So I'm saying there's another representation, right? So in one representation, the action happens when you jump, right? In another representation, the action happens in the node, not on the jump, right? So you could say that, every time I land in node A, in node 0, I'm going to emit an A. Every time I land in 1. So now the action is in the cells, not in the link going to the cell. So if you have a graph, right, and something is supposed to come out of the graph, starting at node 0, you can say that what's going to happen is essentially basically chaining all the links together. That's the sequence of actions. Yes. Another way is to say the links don't have any actions on them. The actions are all inside the nodes. So you have to chain the nodes together to get the sequence of actions. Two different ways, and they're exactly isomorphic. You can convert from one to the other, right? And interesting algorithms you can use to convert. It's very simple, right? So you can do these things. And a trie is a data structure you're going to implement in which you're going to store data in the opposite way, right? And I like that. And it's towards the end of CS2B, and most classes don't teach this. I am pretty sure you can do 2B without having to do this. Not my 2B, someone else's 2B maybe, without having to code a trie. In fact, I think many people just encounter tries or prefix trees first time when they go to an interview, right? So you go to some place, which is a real programming place, not a startup that's just trying to peddle some simple algorithm, but I'm talking a real programming place where they tackle hard problems, right? It's a big place where they have lots and lots of problems. Microsoft, Google, Netflix, right? Those kind of places. And you go to an interview, they want to know if you want to know about tries, right? If you know about prefix trees. So many people I know, this first time they encountered a prefix tree was in an interview. And say, how do you encode this, right? So in 2B, fortunately, you get a chance to actually implement this in one of the quests, later quests. And there you'll see how to make that mental switch. It's like this gust talk. Is that the word? I don't know, right? Complete switch. Looking at this data structure where the data is on this side. No, the data is not on this side. It's data. In fact, you don't see the data in a trie. This is data is implicit in the edges. And it's something that completely throws programmers off. Right, and that's something you have to get used to. But once you get used to it, again, it's like swimming. Right, once you get used to it, anytime you have a data structure, you immediately know. Right, you look at it and say, okay, well, is this stored in this format or that format? Right? So you have to do that mental translation. But it's better to practice that mental translation. It takes a while because and in fact, the first time someone encounters that kind of representation, it basically throws them off. Right, it says it is something that I'm not used to, and because technically speaking, you can still live a profitable, life in computer science without having to know about that, because there's lots of work you can do. But it's really not computer science until you dive into everything that is puzzling and interesting, and say, well, get to the root of issues, right? Not solving little problems in ditches. So yeah, you get to do all that. Where I was going with that was that we have time today. And we're going to play it according to how you guys want. Okay, so if you want me to walk one of you through code like we usually do, I'm happy to do that. Right, someone pick up a screen, we'll say, okay, we're going to code a list and bam, right? So and do these things. However, if one of you just wants to pick up the screen and code anything you want, okay, And you can, shuffle the screen between you guys, or maybe four of you, all of you can code on the same replete window, right? With comments and, and learn the incredibly important skill of working on the same document with multiple people at the same time, right? It's a rare skill, but I think it's going to be common, right? Especially in virtual space and meta reality and so on. It's going to be very important, right? So you're going to have some shared canvas, not a 2D canvas. You're going to have a shared thing, and you're all going to be working on it at the same time. So you may as well start with doing that in a program, which is, as simple as it gets. So open up a program and say, well, hey guys, why don't we do this, right? And then you don't have to all settle on the vision on minute one. You can say, let's start doing that. And as you're coding, you can talk amongst yourselves and shift gears, diverge, and say, hey, you know what? Let's try and change it. Or, is it okay if I modify that? Have fun. Basically, I'm saying have fun. Okay, have fun using all the concepts you've learned, because I think we've covered every single concept in the syllabus, in the state issued CID. I think I've covered every single concept. And if there's something in there that is still elusive, just feel free to ask, right? I'll try and explain it. But I have a feeling that you guys want more time on your own, right? It's not like I'm going to disappear. I'm just going to be here, right? And I'm happy to talk anytime you want, right? And I'm just mindful of taking up the airwaves and the CPU more than I should. I would like, if I'm just here as an observer. Would you guys like that?
Do you work on requests together?
No. So who asked that? You asked me this question before these guys turned up. No, all right. So I see you're asking this question for the benefit of the other people. No, all right, thank you. You cannot work on your quests, okay? Please don't work on your quests, because it's not only for your benefit, right? You'll be spoiling the experience for other people too. And to make it worse, it's going to be recorded on YouTube, and don't waste the opportunity and don't spoil it for other people, and have fun. And you won't have fun if you're working on the quest. You're not going to have fun here. Okay, the only way to have fun with the quest is to work on it on your own. Hey, get away from everybody else. The only thing you should have is probably a browser window so you can look up the odd thing, but you should be coding on your own. The temptation is very high, especially if you have a family member who is a CS person. Yeah, I'm pretty sure most of you have family members who are CS people, or friends, close friends, or dorm buddies. The temptation is very high. Why, right? Even if you're working and you have a neighbor in the other room, because I've done this, right? And you're stuck with something, and you spend like 10 minutes trying to figure it out, and it's going to take like 10 more minutes. You can figure it out, but I can just run into my neighbor's room and say, hey, what's wrong with this regular expression, right? Sometimes I do that, but you have to exercise. Yeah. Some things are fun to do together, but some things are wasteful together. So you should just figure out which ones. Don't work on quests, please. This is just a request. I can't prevent you from doing that, but remember, it's going to be. Oh, I can. If you work on quests, I'm not going to publish the YouTube video, right? I'll just delete it. So you can. So, but on the other hand, you can turn this to your advantage. Work on something interesting that maybe 10 years down the line you can actually say, here's a YouTube link to something I did, right? With my classmates. And maybe put it. Maybe it's so good that eventually you'll put it on a resume, or maybe you start a kick-ass company in the future, right? Multi-planetary company, right? And some social media forum has a link to this video saying, hey, this is this person before they became a multi-trillionaire. Look at them coding up something in class with their friends, right? So imagine. So do something cool and interesting, and something that you can always come back and say, if I'm bored, here's something I can watch, right? Because you can't rely on outside content. You might as well create your own content and do something interesting and cool like that. Is that okay with you guys? I'm not going to disappear. And I will be hearing, within earshot. No, actually, I'll be here, right? If you want me to watch you code, I'm able to sit here and watch you code too. I don't have a problem with that. The only reason I'm not going to do that is because I think it'll cramp your style. Okay. So if you like, what I'll do is I'll be within earshot. So, but please talk, right? If there's silence, I'll come back. If there's silence and I don't hear anything, I'll come back and look at the screen. I can just turn the CPU, the computer around, so I'm not even in front of the screen. It's facing the yard, and you guys can code. And if you call me, say, Anand, come back here. We got a problem, or do you have an idea? Can you brainstorm with us? That's fine. Okay. So we're trying to solve this problem. Can you brainstorm with us? And I'll just come back and just listen to you guys. And I'm not going to suggest anything. When I'm brainstorming with you, I won't suggest anything. And if I do suggest anything, just cut me off. All I need to do when I'm brainstorming is just, listen. And if I feel that there's an idea being pursued that is not going to lead anywhere, then I'll say, no, that's not a good idea. Let's do something else. Okay. And then maybe someone else takes over. So that's the only thing I will do when I'm brainstorming. Okay. Unless you ask me, right? All of you say, even then, I'll be reluctant to give out ideas because you guys are coming up with good ideas, right? So I don't want to stifle them. So is that okay with you guys? Can you guys just code anything on your own in a shared replete window, right? Make it something that is fun for other students to watch later, right? Just have a conversation, right? Think about if you can make this into a video that would actually be a successful and viral YouTube video even. It doesn't have to be, obviously, it's really hard, right? 1 in a trillion, 1 in a billion videos like that. But who knows? Maybe you're just playing around with code and you come up with something interesting, right? And you take a short clip of that and say that's a YouTube clip, like 2-minute clip even. Who knows? You have to give opportunities, right? You have to give opportunities to something for something good to bloom like this, right? If there's no opportunities, nothing's going to happen. So I think that's a good way to do things. Are you guys okay? We have close to 2 hours. Starting now. No, close to 1.5 hours. Are you guys okay with that? I'm going to be around. If you want. The thing is, I'm not getting any feedback. If you want me to, I'm happy to drive. Not drive. You guys drive, and I can walk you through some code for a linked list, like we said before, right? Like we do in other classes. Happy to do that too. What is your preference? Do you guys want to code on your own in a shared replete window? Replete, whatever it is. All of you coding at the same time. Anything you want, right? Doesn't have to be a linked list. Hopefully involving linked structures. Maybe you say, hey, I want to code up a structure in which every node has 3 pointers out of it, right? 3 pointers. Every node has 3 pointers. So, it brings up new challenges, right? How do you create a new node? How do you, how do you create a successor? How do you name the successors? Do I want to go to the left, middle, or right? Right? What if you have many successors, right? 15 successors, and so on. So play around with these ideas, and doesn't matter. You may have memory leaks, that's fine. And you say, hey, I have a memory leak. How can I take care of this memory leak? Right? Or what did I do in my code that caused the memory leak? That's better, right? Even if you don't take care of the memory leak, that's fine. But it's important to come to a situation where you actually do have a memory leak, and you just get to the root of the memory leak, saying, why did I have the memory leak? I don't have to fix it. I just need to know why, so that I don't have that next time. When I design something, I can make sure I don't go down the road. Yeah. So sometimes it's good to have memory leaks that you cannot fix, and say, well, it's a design decision. Because many times we get memory leaks that we do fix eventually. Yes, we get to the root of it, in a debugger, val grind, and so on, and we say, okay, well, that's why the memory. That's how we fix it. But sometimes there are memory leaks that you cannot fix at all, unless you cannot fix. It's not tractable. In fact, there are situations in which you can have a memory leak in which the memory leak is, to fix a memory leak is an intractable problem. And you say, no, that means the design decision was wrong. I created a data structure which grew in a way that did not make it feasible for me to create a proper deallocation procedure. Right. So if you come across a situation like that, you can say, well, there's 2 kinds. There's one kind of memory leak which I can fix. The other kind in which I cannot fix in code, I have to revisit my design decisions. So run into both situations in class, not in real life and when you're working. Right? I'm pretty sure if you stick with 2A, 2B, 2C, you're sure to come across opportunities where you can run into these situations. If not, these are opportunities. You can create a data structure, and you'll find out. Right? So you think, oh wow, now C++ gives me the opportunity to do anything I want. Now I can basically create a data structure like a virus with lots and lots of arms and uncountable, maybe an arbitrary number of arms, right? So and things like that, graphs and so funny kind of graphs. And you say, why are people not doing that? Why are these graphs not popular? Right? Because you can do anything in C++, right? Or in computer programming language, right? Turing. You can do anything, but only certain kinds of data structures are popular, right? Even a trie, which is kind of unintuitive, is popular, commonly used, but there are other data structures that are even unintuitive but not used. And why are people not using it? even though there may be a use for it, right? There are reasons, the solid reasons, right? We don't use those data structures because we don't know of good algorithms to manage them. We don't know good algorithms to construct them, destroy them, traverse them. If we did, we'd use them, but we don't. That's why we don't use them, right? So we come across reasons for these things. So better to just keep on playing, right? Like ABC, always be coding. That's the best way for you to come across these situations, and that's what makes for I think a good programmer, because they know all the nooks and crannies where you don't have where you shouldn't go. Right? So when you go to a new city and say you want a tour guide, why or you're using a tour guide because there are lots of dark places where you shouldn't go, and the guide knows those things. And you can go around and say, don't go there, don't go there. You can go here, you can go here, and so on. Just like that, if you come across a lot of these dark places when you're a student, and say, well, those are places I shouldn't go, then when you're a professional and you're actually coding something out right there in the real world, people will actually want to have you in their teams, or they want you to manage the code, right? They want you to manage a team of engineers because you know where these guys shouldn't go to get shot or some bad things happen to them, right? It's like, play, try and solve this, do whatever you want, but, and I'll just keep an eye. And if you're going to do something that's going to get you fired eventually, I'll just say, don't do that, man, right? So that's really what you want. And by playing around a lot when you're a student, when you cannot be fired, right now you can do all the crazy things you want, you can't be fired. Yes. So this is your chance. This is your chance to do all the crazy things you want that you could potentially get fired for when you're working. So that and you say, well, now I don't have to do all those crazy things because, all of you guys, you want to do those things, right? But you can't because you'll get fired. But I also wanted to do all those things, but I actually did do those things, right? Now I've done those things. I don't want to do those things anymore because I've already done those, right? But I can tell you what will happen if you do those, right? So because I did those when it was safe for me to do it. So I did those and I came out alive. If I do the same things now, I won't come out alive. So I won't live to tell you how good it is or how bad it is when you do it, right? When I was a student, I could do those things, right? And I was still alive when I came out. So now I can tell you guys, don't do those things. So those are good software engineers to employ, good engineers to have manage your projects because they know what the wrong decisions are. Good managers usually know what the wrong decisions are, right? Rather than, because there are many right decisions and many wrong decisions, and you can do a right decision and be safe. But once you do a wrong decision, the whole project could basically get tanked, and that's that experience you'll pick up, right? I think that's a luxury that students have. Nobody ever told me, but when I was a student, I was very fearful of experimenting, even with computers, right? In our computer center, I know, right? So students, as a student, I was very fearful of experimenting. And now that I think about it, later on in life, I was a lot more fearful of experimenting with things that could basically break. But that was justified fear because, if I break things, I screw things up for a lot of people, not just me, my colleagues, my company, a lot of money could be lost. So that fear is justified. But I had the same fear even when I was a student. And then I think back and I think that, when I was a student, that fear was not justified. And basically, I shortchanged myself by not trying out a lot of things that I could have when I was a student. Lots of things you can do now, right? But you can't do when you're older. So do them, have a lot of fun. You still can do them when you're older, but you have to give up a lot more, right? It's more risky. So now is a great time. So play around. All right, enough of a lobbying call for the other project. Okay, so you have a choice. Tell me what you want to do. You want me to walk one of you through the code while the rest of you watch, or do you guys want to just get together in a shared window and code, and I'll just be around, right? I won't even watch you unless you want me to, right? I'll turn it away, and so that you can just code, and you can call me anytime you want to ask any question. Is that okay or not?
Yeah, that's okay.
2 more people. Yes.
Yeah, that sounds good. I'm just curious, how many have completed Quest 9 in here?
I'm on quest 9.
Okay. Okay, so it's just me. Then I'll try to not do anything as much.
No, don't do anything related to quest,
Right.
please. Hey, Jared,
yeah.
you're okay with this too? This arrangement?
Yeah, sure.
Okay, good. All right, don't talk about quest, please. And
Oh, yeah, I mean,
just play around with lists, and you'll be fine with quests. Okay, don't worry about it. I can.
was thinking
Shall I just turn
maybe-
the computer around, and I'll be around. Don't worry. Okay, and just call me if for anything you can just call me back. Okay, is that all right?
Yes.
Great. Okay, and if this works, let's do the same thing on Thursday also. Right, that's the last class of this quarter. Okay, the this Thursday is the last class. Next week is the finals. Although I should say, I'm happy to give you a class during next week also. Right, anytime I'm happy to give you a class. Just call me, or let me know. Let me know. Right, email. Bunch of you get together. That's fine. Okay, so.
Yeah.
Happy coding, enjoy yourself. I'm just going to be around. Call me if you need me, okay? And
Okay.
pointers, make sure you use pointers and memory allocation. And always, Hiram, you know how to use val grind, yes? Val grind.
Oh,
Oh,
I've
no,
used
no,
it
if you have
before.
not heard the word, don't worry. Okay, just
Okay.
after you write the code using pointers, new and delete, do a check amongst yourself. Is all the memory being that is allocated being deallocated? You need to make sure that there are no leaks. And do that visually in your mind using your eyes, right? It's a fun exercise without having to use any tools like Valgrind, just by looking at your code saying, hey, is there a chance for memory leaks? And then Jared says, hey, I think this might do a leak, right? If you do this, there'll be a leak here. And you fix that. And Hiram says, no, that will also, right? So that's all great fun to have, right? Excellent conversations. So, create something and find out if there's going to be a memory leak. Yeah? Do various operations with it. All right, enough ideas, right? Okay, enjoy coding. Okay, happy hacking. I'm going to be around. See you guys soon. Okay.
Okay.
And call me before the end of class. Okay, I'll just come and say bye. And Thursday there is class. Tell everybody there's class on Thursday. All right. I'm going to be here.
You guys want to review for the final by coding?
Sure.
I'm okay with it.
Okay. Then you want to use Replit?
I like Replit.
Sure. All right. Do you want to make it or do you want me to make it?
I've made it a lot of times. Maybe you should make it.
Sure. Okay. Just give me a second. There's a link I put in the chat. Does that work?
Not exactly. I can't edit it.
Oh, maybe I have to set something. Give me a second. Try this one.
Great, that worked. Yep. Okay. So what should we make?
Let's see. Let's first. Do you remember do you know what's going to be on the final?
No,
There
I
should
don't.
be some
I'm
sort
gonna
of,
guess.
some sort of list in the syllabus.
I would just guess everything that we've learned.
Maybe we can just start by making a class that has to be on the final.
I mean, yeah, but so it would be like all the functions and
Yeah.
I guess the classes are probably a pretty good way to do everything, but I don't know what kind of class we should make.
Uh,
Uh,
maybe just a simple class to practice making classes.
yeah, but like, what do we want it to do? Otherwise, like,
Uh,
we could just do a class of lots of functions like we did for a lot of the quests. We could make something that actually we want to use, like the, what is it, quest 7? Those quest 6 and 7, the ones that we actually used the classes for doing stuff. I don't know.
what was quest 6 and 7?
Oh, the pet and the pet store.
Pet store. Okay.
So, I don't know. I'm just trying to throw out ideas.
Yeah. Maybe we'll make a food and a food store.
A restaurant.
Yeah, restaurant, not food store.
Sure, we could do that, but like, yeah, why not? Why not?
Okay.
Yeah, let's do that. Sounds great. Okay, wait. Just a sec. So we're gonna want another file for food. Very nice. Do we want a food.h?
Yeah, how does that work exactly? I've really just been copying it from the template.
Oh, so wait. Okay, so the header files are like the declarations of what a class or another file will have in it. So if we say like in the header that it has these variables and these functions, then in the CPP file, then we can fill all those functions out. The header is
Okay.
almost like has all of the signatures and stuff.
Sure, okay. And do you always need both .h and .cpp?
No, you don't. You don't, because you can just include the .cpp if you're just going to put, or you can just make a .h if you're going to put all of the functionalities in the .h, because in the .h, in the header file, you can also include like one-liners, so that like if
Okay.
you just are making a getter, then you can just put that in the .h. There's no good reason to put it in the CPP.
All
It's
right,
mostly just to separate complex code out, I think.
okay. Sure, then let's make one.
Okay, so food or something? Wait, what should we call it? Class.
Food is fine.
Okay.
Yeah. Maybe we do.
Then what do we want?
We can have a color, and it could be healthy or unhealthy.
Okay, so we're gonna want. So are we gonna make getters and setters and private stuff?
Sure.
Okay, so then we're gonna want stuff
Yeah.
like, what attributes do we want? We're gonna want a name. Oh, oops. Let me, yeah. Make a line after that. Okay, we're gonna want a name. Oh, do we want to use the notation with the underscore for private members? I don't know. Oh, shoot.
Yeah, sure.
I'll change my settings for a sec, because my settings make it so that tab is 4 and yours are 2. There. Okay. What else do we want? Healthy. We could like actually do information about it.
Color.
Color. Okay. What about? Wait, string vegetable. Don't we want a bool there? Like we could say bool is vegetable. Oh, are we using camel case? Shoot, vegetable. Oh wait, shoot. Are we gonna use camel or snake? Okay, we're using camel. Got it.
Maybe we'll just stop right there. Like that's 5. That should be good.
Yeah, that should be plenty. Okay, so now we're gonna need to make getters and setters for all of those. Do you want to make the getters or the setters?
I'll do getters.
Okay, then I'll try to make setters. Wait, that probably means I should be below you. Whatever. Okay, so we're gonna want setters, huh? Cool. Set name. Remember that the getters can be const.
Okay. Is that necessary?
But it's good. It's not necessary. It just makes it so that while you're coding inside the function, you can't make any mistakes that change
Oh,
the
okay.
variables.
Okay.
Set name. Cool. Set. Suspension. Cool. Suspension. I had an interesting idea. We could use an enum for color.
For color?
Yeah.
Yeah. How did those work again?
Uh,
I know it's like there's a few options and you can only do one of those options, but I don't know how to set it up.
okay. I'll look at a spec to remember.
Oh,
Or I
okay.
could just search it up. I think it was like in the declaration you make this class. I think you have to say like enum, and then you say the name of the type of the enum, the name of the type. Right? Yeah. Well, let me see. That might be too complicated. Let's just use that. Is it okay if I restructure the variable like ordering? Because I think that like is fruit should be right after is vegetable.
Sure.
Okay, I think I've wrote all of them out. Yeah, okay, so now I just need to do them. Conditions. Name cannot be empty. Is vegetable cannot be null. Fruit cannot be null. Color cannot be empty. Oops, I did make a mistake.
Are you should we help out?
Yeah, go ahead.
Okay. still need the food.cpp file.
That's a good point. Because the thing is, if we're just making like really short functions like these, which are like 3 lines at most, and wait, shoot, who is this?
Maybe we can make another function to put in the CPP file.
Yeah,
just
I was
to
thinking
make
like,
it-
I don't know, we could say something.
if it's the color is blue and it's unhealthy, then we print a string saying this is very, very bad for you.
uh, that's pretty funny.
Okay, let's just, so how would we do that in food.cpp?
So what we're gonna want to do in that case is we're gonna have a public function, right? We'll put it at the end since we have tons of. Oh, by the way, for one-liners, it's sort of nice if you format them like I just did for get fruit at the end because they take up a lot less space and are more readable that way.
For oh, I see. Yeah. Okay.
But yeah.
Okay.
Okay.
Right,
So yeah, at the end we're gonna want a new function. Wait, so it's gonna be like a string. Do we want it to return a string or just straight up print it?
Why not return string?
Okay, so we're gonna want string
Uh,
advisement or something.
yeah, advice. Sure.
Advisement,
Then,
const, because it's not going to change anything about the
Uh-huh.
fruit. And then we can just say that, I believe.
okay. And then what do we put in food.cpp?
In food.cpp, we now need to write food, double colon, advisement. And I believe we want, I forgot string food. Oh, shoot. I just realized.
Oh, using
Yes.
namespace.
Yeah,
Yeah.
using
Yeah.
namespace
That
std,
go
and
to-
on top of that, we also need include food.h. Okay. Oh shoot, I capitalized? Why are our file names for food not capitalized?
Oh, they just aren't.
Okay, well I guess that's fine. Usually for classes, I think we want to
Oh, okay.
capitalize them because it makes it more like a class, but it's fine.
So
Unknown type name string, you'll get used to it. We just put the std. We also forgot it up here and we were using strings. So, oh no, it was there.
Oh, I
Very
put
nice.
it in just now.
Thank you.
Okay. If
Okay, do we have anything else that we need to include? I don't think so for the .h. So I think we're good. Okay. So let's see. Like if the color is blue and
Yeah.
it's not healthy, not as healthy. Do we want to use our functions for that? I doubt it.
Oh,
Could.
right, we could.
Our getters, that actually would probably be best so that we can like change it how you access the members if we ever want to.
Yeah.
So we'll want to say like get color or something. Yeah.
Yeah.
Or do we need the, oh shoot, that would be annoying. Oh, it's, I formatted them like this.
Oh, okay.
Cause it's,
No, I don't.
or, oh shoot, you formatted the get
Yeah.
colors differently. Sorry, I'm so,
It's okay.
oh my gosh.
And it isn't helpful. So
Not, wait, no, that won't work. You're gonna want, oh
what
wait,
was
no, sorry. You're right, you're right.
that?
You could probably get rid of the parentheses, actually. I don't know.
Oh, okay.
Probably. I think
see.
so. It should be fine.
Return.
Oops. Yeah. Let's see. What other things can we say? If get color equals green and let's say get vegetable. Yeah, this is why I liked using the snake just for the behind the get, because that way I could say like get is vegetable, so that it's more clear that it's a vegetable name, but
Yeah.
it's okay. This is great.
Okay.
Get vegetable and get healthy, like this, right? Then we can say
Yeah.
return this is very, very good for you. I don't know. Like
Yeah,
that.
why is there a
Oh, are we
red
adding
line?
huh?
Right. Cannot
Why is there a red
return
line?
constant integer.
Interesting. Type int. I think
Maybe you
that
have to
there's
do
something wrong
something
with
like.
REPL.
Oh, really?
Probably.
Okay. Unknown type name string.
It's probably an issue with REPL, yeah.
Okay. All right.
I
So,
really.
all right. So now we have some functions. Oh, do we need to put a public in these?
Let me check something actually, just a second.
Oh, we don't have to put public because it's here. Okay.
Yeah, it's already there.
Yeah. All right, then why don't we make an object? Oh, what about constructors?
Construct. Oh, yeah, we need that, huh?
Or
Yeah.
just
Okay.
do
So
an empty one and use all
what?
the getters.
What do we're gonna want like food? Oops, that's weird. And then in the food class, in the food function, what do we want? Do we want to pass some stuff into it, like inside the constructor, or do we just want a constructor?
Um, maybe we can just pass in name.
Pass in name.
Yeah,
Okay. String name.
yeah. Now we can practice using both constructor and setters.
And then we're gonna want name equals. Oh wait, probably should set.
And then you set everything else to false. What? Yeah.
Set is fruit false. Set is vegetable false. Oh my gosh. What else do we need to set? Is healthy and color. Okay. Set is healthy false. Set color. White. I don't know. I set the color to white for the deep.
Okay, sure. Um, so the main.tpp, I wrote a one line in the main function. Is this how you do it, or is there some sort of pointer thing?
New is a pointers thing, so we don't need that. I don't think.
Don't need new. Okay.
I don't think so.
Like that.
Equals. I feel like that's wrong. Let me check. Let me check.
What was that?
I feel like it's wrong, but I don't know why.
Oh, yeah, we can just run it. Yeah. Okay. Apparently, there's no namespace std.
I've added that, I think.
Where it's pointing it. The error isn't but now it's okay.
Get in.
Oh, that's just a warning, not it.
That didn't help. Yeah.
Do we need to include the other files in the main TPP?
Oh,
Oh,
yeah, that's right.
that's it. Yeah, we need to include food.h. Or do we need to include food.cpp?
I think it's food.cpp and then food.cpp includes food.h.
That's weird though, because I think you usually want to include the H.
Just try it.
I think you
Do
do
both of
want
them.
food.h. Yeah, that's true. Maybe it is nuclear. No, that just seems so wrong. Yeah, it doesn't like that. Oh, maybe it didn't like that we were past. Oh my gosh.
Identifier null.
Oh, that's weird. Doesn't like me using null, huh?
I
And
can't
I
even
guess.
tell where the errors begin.
Oh, the error? It's in my setters when I checked if the Boolean variables were not null. I suppose that we can just do
Oh,
away with that check.
is it null pointer?
No,
Or
it's not null pointer because
it's
we're not
actually,
checking a pointer. So right. Let me see if capitalized null is what it is.
oh, okay, I see. Or maybe,
I don't know.
no, yeah.
I just remember using null a lot
Or
when I
maybe I
was.
think Boolean is always is initialized to be false.
That's probably true. You know what?
So it
Let's
can't
just get rid of the
possibly.
checks in the
Yeah.
Boolean ones.
Okay, sure.
That'll definitely fix the problem, and I don't think we really need them. So yeah, that should do it. Why is it so certain that it doesn't want us to return that inside a string here? Unknown type name string. Do we actually need to include string? That would be awful.
We're already using namespace std.
Out of line.
Is there something we need to include? Oh, yeah, well, we didn't include string in food.h.
Any declaration. Out of line. Oh my gosh. This is. What the heck?
Okay.
Yeah, sorry, I'm trying to
Let's
figure
do
out
it.
what it is. Const.
Remember-
Oh my gosh. There. Get color has this argument has type const food. Function is not marked const. Oh, that is so weird. What the heck? Okay. So it doesn't like us using our getters
Mhm.
because the input for some reason is a const. Whatever. I guess we should just not use them. That's so
All right,
weird.
sure.
Yeah, you can change that.
Or is that it? Oh, we
No.
still have a, yeah, okay.
Okay.
Run it.
Oh, you forgot a parentheses.
Oh, okay. Is that, okay. One warning generated. Okay, so that's done there.
Control name each the. Oh, I see. So the advisement string currently can return nothing. So let's make it just return like
Oh, okay.
I don't know, no recommendations.
Yeah, okay.
Okay.
So now, why don't we set everything for Jolly
Yeah.
Rancher?
So we already have a name. So now we just need to say Jolly Rancher. Oh, oops. Just a sec. Can you stop typing? Never mind.
Oh,
Never mind.
yeah.
I'll do it from the other direction. It's okay.
Okay.
Wait, it's not. Oh, yeah, it is. Okay, sorry. Jolly Rancher dot set is vegetable true.
Sure.
Definitely, it's a vegetable.
Yeah.
Jolly Rancher dot set is fruit. Jolly
Done.
Oh wait, yeah, the color is the last one.
Set
Okay.
is healthy.
Oh, yeah, okay. Is healthy. False. Definitely. Okay.
All right. What else?
Dude.
Oh, name's already set because
Yeah, name's already set because of our constructor.
okay. So now C out, then Jolly.
Wait.
Advancements.
Okay.
Is there any print? No, there's no print.
Yeah, that should. Oh, do we want the endle?
Oh, or no. Yeah, you're right.
I think it already does an Endel when you
I
return
think
it.
in one of
I
them.
see.
Yeah, this is very bad for you.
Okay, maybe we should include the name in our like advisement. We could say like,
Oh, okay. Jolly Ranchers are bad for you.
yeah. Uh,
Should we do like an L?
name plus
Oh, never mind.
like that maybe.
Sure.
Actually, wait, no. R. Okay, maybe that'll help. Okay, so maybe we need to make sure that our name is plural, or should we just?
How would you do that?
No, it's fine. We can just add an S.
Okay. Okay. Yeah, Jolly
Perfect.
Ranchers. Okay. I'm looking at
Okay.
the syllabus.
Do we need the backslash
Yep.
ends at the end? I sort of feel like we don't want them, right? Because we
Yeah,
can
sure.
determine
We can
that
take it out.
ourselves.
Okay. All right. Looking at the syllabus, the next thing to that we learned was methods and parameters. Yeah, we've used methods and parameters. Next thing is pointers and memory management.
Okay, wait. So maybe pointers and memory management.
Oh, first of all, what's the difference? Remember typing in a main.cpp between type and
There is no difference, but here's what you have to be careful of. If you go type star, right, and then you type out name, right,
okay.
then only this one will be a pointer.
Oh, okay.
So that's why it's better to go type star name, star name, star name. Does that make sense?
Okay. Yeah, that makes sense. Okay. Why don't we just put some sort of pointer in food?
But what? It's like,
Yeah.
do we really need a pointer to anything?
Well, we don't need it. We just to practice.
Just
pointer.
because. Just
Yeah.
because. Oh gosh. What would we use a pointer for food?
Yeah, that's the thing. Yeah.
pointer for food.
We could make a linked list of food. So
I mean, we
food
could.
points to the
Uh,
next food, which points to the next food.
So maybe we could make a quick, yeah, a node struct.
Or all we have to do is add an extra what's it called? Instance variable. Yeah, to food. That's next food. So food,
Hmm.
or I added it in food.h.
The problem for me with that is that there's no good reason for every food to have a next food.
Um,
Does that make any sense? I feel like it sort of
I mean,
doesn't.
there is no good reason to make a food CPP class. We're
Yeah,
just doing it to practice.
yeah, that's true. I was just thinking like we could do it this way. This would be fine.
Okay.
Remember though, I'm just gonna be a
All
stupid
right.
for the notation. We can't know the next food, can we?
Well, we could initialize it in the constructor to null pointer.
Now we're gonna need a destructor, huh? Oh shoot. Okay. Yeah, I don't know if I like this. Because we're gonna have to set up an entire another like data structure inside food, and it just seems awkward. I think it would be
What
better
about
to make an
in main?
yeah, I was thinking that we could just do it in main.
Oh.
I'm gonna just get rid of the next food stuff from in here. Sorry.
Yeah, that's okay. Wait, but if there's no if it doesn't have that attribute, how are we
Right,
gonna
so here's what I was thinking of doing. What we
Okay.
could do is do I don't know where to do this actually. I think you might want to do it here. Well, whatever. Struct node, right? We could just make a quick node here, right?
Oh, and then each node has a food.
Yeah, that's right. For its data, it's just food. So we can say it's got a food, I don't know.
That's about
And then we have a food star, no, food star next food, right?
yeah.
That's it,
Okay. Or no, it
right?
should be a node and then star next node.
Oh, you are right. Thank you.
Yeah.
Okay, so now we have that, and we can just go through this, huh? Yeah. So, what? It's a little awkward though. It still is awkward. Whatever.
So
We can make a node like
yeah, we need a
node,
node.
node. Wait, should we make a
Maybe
loop
should
to
the
make
node
one?
come after making Jolly Rancher?
Oh, that's a good point. We might want to do that. We could do node. Okay, so what we need to do is create pointer. Okay, so node star star. I don't know, head
Okay.
equals new node. I don't know.
So how come
No,
we
we do make
use
it.
new here?
Because this is a pointer, I believe.
Okay. So is it node a class? I mean a struct, so that you don't need the parentheses? Or do you?
I don't know. Let me check something.
Okay.
Oh, I see. I see. Okay, we need a constructor. No. Food here equals, food. Um, that's weird notation. Um, oh, shoot. Haha. We don't need these. Food. Food. Shoot. That's sort of awkward. What do I want to call? Whatever, it's just an
What's this?
initialization.
Oh, this is how you initialize a node? I mean, a struct?
I think so, yeah.
Oh,
Node term. Yeah, okay. And now we can pass it. Shoot. Node. Okay.
Yep.
Okay, so that seems to have worked. What the heck happened there? What? Okay, so now we have that first node, the head node. And we're going to want to keep a node of where we are. So let's say node current
yeah.
equals. Oh, shoot. No, that's not what we want. We want that after. We want node current equals head. There. So
Okay.
now what we have is a node on the heap, with the pointers head and current pointing to it.
Yeah.
And that node is Jolly Rancher.
Yeah.
Okay. So what?
Yeah. So we just make a couple more foods.
Yeah, I guess we do.
Yeah.
Okay, so now we're going to want a new food like
Oops.
salad. Okay. Salad. 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 That's. I mean, you could have fruit in it.
Yeah. But
Let's say no.
yeah. Okay.
And then we're going to want the node star, right? So we're going to need to say,
Yeah. We need to make a node for this.
how would we need to make this a thing. Let's see, how would I do this? Okay, that works.
Then we need to set the next node pointer of head to this node or current to this node. So something like that.
Yeah, that looks
Yeah.
good.
Then current moves to this
Let
node.
me see. You could do that.
Yeah.
Yeah, both of those work.
Okay. And then So let's see if that worked by printing out the advisement for,
Now we're gonna want head, right? So like this, head,
oh,
oops, sorry,
you
sorry,
check.
head, head, then we're gonna want
Oh, and then food,
food,
and then dot. Or why not?
what the heck was it?
Uh,
Wait, would it be dot? Yeah, it is dot, huh? Food dot
advisement.
advisement. Let's hope that works.
Okay. And then I'm gonna run it. Let's see. All right.
Interesting. It happened twice. Of course it did.
Yeah,
we have this
yeah,
out
that's
here.
'cause,
Let's get rid of that.
sure. And then
Nice. So that actually worked.
let's see
Okay,
if
so then
it
we just need to
added
copy
salad correct.
all this, right?
Or let's first see if it added salad.
Oh, right. Yeah. Okay. So wait, before we do
Correct.
that. Oh, yeah. Yeah, that works. It would be really convenient to make like an actual like list right now, but I'm not going to.
Oh,
Yay!
all right, all right. Salads are very
Yeah.
good.
Okay.
Okay.
Well, in this case, let's go. Let's copy all this,
Yeah.
and then we're gonna want another one.
All right. How about one that won't give any advice? It's like banana.
Banana. Banana. Banana.
But is banana a
Banana.
fruit though?
Banana.
Yeah. I think bananas are fruit.
Banana.
Yeah.
Yeah.
Yeah. Food, banana. Okay. And then we just need to add equals new node.
All right, because it's moving. So
So now that when you call on current right here, it will call on banana or
yeah, it should call on banana.
okay, it'll skip past salad.
Right. Because up here we're moving current.
Yeah.
And then we don't need this because it'll just print Jolly Rancher again.
Wait, no, but I didn't copy that. That's the same thing.
Oh, what do you
We
mean?
only have those cout statements at the end. There's no other cout statements in this.
I see. Yeah. Then
Let's just see what this does, and then we can redesign our couts.
yeah, it should print
Should print Jolly Ranchers and banana.
Banana.
No recommendations. Yeah. Okay,
Yeah.
that makes sense.
All right.
Okay, so now the way that we want to do this is say current equals head. Okay, so we reset it to the beginning, right? And then what I like to do is a little cheap, but while current next node is not equal to null pointer,
Okay.
then we can loop through and say cout current food dot, I cannot type, dot advisement and all.
Yeah, okay.
Right, and then we can just
Shouldn't it be a current, not current next node? Because then it wouldn't print the last one, right?
Oh, you're right. Thanks.
Yeah.
I made that mistake in my
Oh,
thing. Okay, let's see what that does.
all right. Whoa.
Oh no, yeah, that's bad. Let's add that next node again.
Oh no, you're not moving. Oh, let me first stop it. You're not moving current.
I'm not
current
moving.
structure.
Yeah, that would be important.
Okay, hold on. How do you stop this? Oh.
Okay, there. That's an. Oh my gosh.
Oh.
There.
Nice try.
Let's get rid of this too. Okay.
Oh yeah, because it didn't print banana.
Yeah, sorry. I
Okay.
made the wrong edit.
All right, there we go.
Great. Okay, now I didn't. Now we actually have it move forward. That's good.
Yeah.
Okay.
Let me see. All right, so we have done pointers and memory management.
Yeah.
Oh, we also need to know algorithms and searching.
Sorting. Ew.
Oh, and sorting. Yeah.
Lovely. Then maybe we could have, we have this, I guess you could call it a linked
Yeah.
list thing of foods, right? So why don't we just make a normal like vector of foods and like do the sorting and such and searching through that?
Okay.
Because I think there's not much you can do when it comes to searching or sorting through a linked list. It's really hard to make it efficient.
Right. But
So
doesn't it have to be numbers? Just for sorting, it has to be numbers
what do you mean?
because there's no order to sort like a banana or a salad. Which one comes first?
Yeah, there is. You can compare their strings.
Oh, okay.
So you can sort it alphabetically like that.
Okay. All right.
Because of the nice little feature that ASCII increases as you go further along the alphabet.
Uh-huh.
So
Okay. So you want to make a vector.
do we want to comment all this previous stuff out so that we don't get weird stuff? Or do we just want to leave it there?
Oh, one thing we didn't do was call the destructor.
Oh, you're right. We need to destroy everything, huh? Did I write the destructor correctly?
Yeah, you
Oh, wait, there is no destructor.
oh, I thought you were okay.
We just need to delete. We need to go through and delete everything. So we need to go current equals head, right? And then while current not equal to null. Oh my gosh. Pointer once again. Then we're gonna do delete current. Oh shoot, no, that won't work. No.
You leave
Node
current first and then
star delete.
yeah.
Oh, del maybe equals current. Current equals current. No wait, we can call it del now. Huh? Del next.
then
Why does it
delete
not
del.
like that? Oh, next node, next node. And then delete del.
And also what about the food object?
The
Or
food
oh, there's no
object?
memory that was made with the food object.
Maybe, yeah. Maybe I think there probably is, but it's automatically deleted since it's not on the heap. It's not using pointers.
Strings aren't on the heap.
Hmm?
I said are strings on the heap?
Not exactly. It's only if you use pointers. Pointers are what put things on the heap.
Okay.
And the new operator.
Mhm. All right.
That's what allocates memory. So if we don't use the new, then we don't need to unclear it.
Okay, got it.
Or deallocate. Oh my gosh, my language. Okay.
Okay. So that deleted everything. Wait, they have it?
I mean, yeah, it said that you just didn't specify an operator.
Oh,
Um, this is fun.
you want to? Sure. Why don't we just see if it works? Whoops.
Let's see. How do we use you?
Oh, it has to be the dot slash thing, right?
What?
Valgrind, whatever you type to run it.
What? Oh no.
All right, yeah, it's okay. It is official.
Valgrind. Valgrind. Okay. Help debug, run silently, be more verbose. Maybe like Valgrind v main.cpp. Is that it? Yeah, that's what I thought. Okay. I don't know how to use you. He was like, you know about it? And I'm like, wait, what?
Oh,
Uh,
yeah. Oh, you probably have to do the GCC thing. to get
Oh, you're
a
right.
dot
Well, I
slash
mean,
something.
what you want to do is in shell, you go to like, this is how I always run my program, but you have to go G++, right? And then you
Oh,
say
G++.
main.cpp output main, right?
I don't think you're typing anything.
But I'm doing it in the, oh, that's interesting.
Or maybe I just can't see it.
I'm in the shell, not the console.
Oh, okay. Yes.
So something happened there. Maybe, oh, I forgot something. G++ main.cpp, and then you also need to say food.h. Oh, main. Is that it? Or is it? No, it's food.cpp. Oops. G++ main.cpp, food.cpp, main. Why am I so out of this? And then you get this main file, right? So if I do an ls, then now we have main here, right? And then I can do /main, and that runs it.
Okay.
So in this case, now we have this main executable. Maybe.
Oh, we
I don't
have
know
it.
what to do with that
Kind of
though.
looks like.
Uh,
Okay, so Valgrind slash main. Do you see it moving on the console?
oh, you're right.
Yeah. All right. So it's
All heap blocks were freed. Now I know how to use this a little bit. Yay.
yeah, and there's other dash things, flags you can use to give for it to give other information.
That's
Yeah,
so
all right.
cool. Okay, yeah, I should definitely learn how to use that.
Okay. Let me see. Right. Vector. Food.
Right, okay.
Um,
Vector of food. Lovely.
vector.
Just a sec. There.
Oh, all right. How do you do it?
I think I forgot how to initialize a vector. Oh my gosh. I think you just need like this. You say like you have, I don't know,
Oh, that's
3.
it.
We don't want too many.
Okay.
I think so.
Oh,
And then we can say foods.
yeah.
Oh gosh. Messed up my cursor. So we could probably
We
say
still
something
have
like,
Jolly Rancher salad and banana from above.
yeah,
right?
let's do the same stuff. Yeah,
Yep.
we still have them.
So Jolly Rancher. Well, that's
Foods
push back. So,
push back. We don't want that.
what do you mean?
We don't want
Food.
pushback because we already have all our space. So we just
Yeah,
need
you're
foods
right.
like 0 equals Jolly Rancher.
Okay.
Oh, semicolon. Salad.
So
Okay. So now that we have that, our foods should be fully. Let's make sure. Let's just print everything out.
oh
Ooh,
wait,
interesting.
something is wrong.
No arguments were provided. Weird. Requires single argument name. Ooh, this is weird. Oh, I think I'm gonna give string name a default value, okay?
Oh, okay.
Default value of unnamed.
Okay.
Okay, that
Okay.
worked.
That works. Anyway, so what happened there?
So what happened was it tried to call our constructor to make the food objects in the vector, right? But our constructor
Yeah.
needed a variable name. And the problem with that is that we weren't
Oh.
giving it a name.
Wait, but
So
didn't we make the Jolly Rancher salad?
yeah, but we weren't passing those into the vector, right? We weren't giving the vector it was constructing its food objects, right? So that it would have the
okay.
space, and it used our constructor, which asked for the string name, and
Okay.
we didn't have a default variable, so it just crashed.
Okay. Yeah. So right now, what's in the vector isn't what we made above.
Huh?
What's in
I
the,
believe it's a copy, most likely.
oh,
It
it's
could be a
copy.
reference. I don't know.
Okay,
We could test.
sure. Let's,
Change foods to or something.
what was that?
Huh? What are you doing?
I was gonna go loop through and see if we get the same advisement strings.
Oh, no, that we would get them no matter what because the data inside them is the same. What we need to do is test if we change one of them, the other one changes too. So let's say that we say Jolly Rancher dot set color green, right? Because now we have a green Jolly Rancher, still fair, right? And then we can see if now we can say like cout foods 0 dot
Oh, I see.
get color. And oh, sorry, it's not that. It's get color with camel. Okay, like that, right? Oops, something happened.
Yeah, so it looks like it's completely different. Or the objects are the same, but if you change, but there's two of them.
Wait, did you guys get a result from that?
Or you don't see it? I'll run it again. It said blue at the end.
Really? Oh my
Last
gosh.
out.
For me, it's just crashing. For
Are you
some
in the
reason.
shell? Or?
I'm in shell. Sorry, no, in console. I'm
Console?
watching you do it. Oh wow, it worked that time.
Okay.
It just took forever for some reason.
Okay.
Sorry, it might be my lag or something.
Oh, okay.
Because REPL is online, so you
Yeah.
can't really trust it to be perfect.
So yeah, changed foods 0.
Yeah, so it is a
Changed
copy,
Jolly Rancher.
not a reference.
Yeah. Okay.
Because if it was a reference, it would have changed with Jolly Rancher.
All right.
Okay, that's good to know.
All right. And then so linear search is you go through and search.
This
What are the other algorithms for searching? Or none of them work unless the list is sorted, right?
Yeah, most of them only work if the list is sorted. Well, the only one that we know works if the list is sorted.
So linear search, like, yeah, linear search is the only one.
Because, yeah, unless you already know something about the vector, you have to look at every element, right? Which means that it's at best linear
Okay.
for search.
All right, then what about, well, what's going on here? Did it just break? Or do you see the Jolly Ranchers are? All right,
What?
someone must have. What about sorting? What sorting algorithms should we know?
The only one that I know right now is really stupid. Sort foods
Oh,
with the condition, right? With a lambda condition, but yeah, we shouldn't use that.
yeah, I forgot which one
Let's see.
we learned.
Let's see, what sorting? So I know a few sorting algorithms. They're just hard to implement. So wait, do you guys know any for
Do
sorting?
the linear search algorithm.
Oh, we're doing sorting right now.
Sort.
Oh, sorting. Sorry.
But I mean, yeah, linear isn't really an option for sorting, huh? Let's see.
Minimum sort, right? Where you take the minimum, move it to the front, and then do the same thing on a smaller.
I see.
Smaller list.
You like look for the minimum, which is a linear time sort, or yeah, it's a linear time search, right?
Right. Yeah.
Linear time search, and then you move that one to the first,
Oh,
and then you have to
yeah.
do that factorial times, huh?
Then there's also one
Wait,
where you
no,
do the same
with
thing with
factorial
the
length.
maximum.
So yeah, that kind of algorithm would probably be pretty bad. It's not quite factorial. What is it?
Then
I guess
there's a
it's
sampling.
quadratic technically.
Yeah, I think it is.
So we could use that. That's probably the simplest one to implement, right?
Sure, let's do that right now.
Let's just do it. We're not using big arrays or vectors, so
Only to be honest.
whatever.
And so we're comparing color.
Wait,
or,
so wait, do we want some like helper functions just because? Like
what would we have?
find minimum?
Okay.
Are we doing minimum sort or
Yeah,
maximum
sure.
sort?
Yeah, let's do that.
Okay. So let's do minimum sort. Then we can say like, I guess it's a
It has
food,
to be a
right?
vector.
I guess, yeah, we don't want to make helper functions since it would be like so specific. Okay, so
So
what we're gonna want to do is, so a while loop, we're gonna need to do this. While what?
or it should be 4 actually.
Or, okay, yeah, that makes sense, since we know the number of times that it'll have to run. Ugh, I know that size t is like the right thing to use here, but
Just
seeing it is
do-
always so annoying.
Yeah,
'Cause, like-
you can switch it in. Yeah.
It's not a big deal. It's just, you forgot an equals 0.
Oh yeah. Okay.
Sorry.
Right, because it's only can happen 3 times. And
Yep.
then
So yeah,
in
this is gonna
each-
happen 3 times. Each time we're gonna need to find the minimum, right? So
Okay.
that's gonna be another 4. Wait, why'd you use x? Don't we usually like use I, j, k?
sure, you can use that.
It's fine. We can just do that. It's fine. Oh, you're right. Food minimum equals.
Just
Wait,
need
we
to
don't
do that.
know. Okay, we don't know. So we're gonna need another 4. Size t y equals 0. Y is less than 3. Y plus plus, and then we're gonna
Or
want.
isn't it y is less? Oh, y is to start at x.
Oh, you're right. Thank you.
Yeah.
If
Well, how do we compare names?
shoot, what is it? Foods I y dot get name less than
Oh, it's just that.
foods. I know.
Oh,
Y
it's
dot
something different.
y plus 1 or something. No, that doesn't work.
Oh,
Y.
we have
Wait, no. We just want
minimum. Compare it to minimum.
minimum. Yeah.
We have to set
Minimum dot get name. Oh, bro. Name. Okay.
Oh,
Then 2 things need to happen. So we're gonna set. Why do we have min in a min index?
because you need to hold which index the minimum is at.
Do we?
Or to switch it.
Oh, you're right. Thanks.
Yeah.
Okay. Shoot. What was it? Min index equals y.
Yeah.
And minimum equals foods. Why do we need minimum then?
Because you need that to compare the other names.
Oh, you wait.
Or hold on.
Foods.
It's just foods x. Right.
Foods x. Yeah. Also, we might want to define this out. No, wait.
Each time
Yeah, each time we're gonna find a new minimum. I mean, you could do that. Yeah. Yeah, that makes sense. Okay. Alternatively, we could just use min index and not have a minimum. That would probably be better. Because
Okay, sure.
what we can do is set min index equal to x, right?
Yeah.
And then we can say foods x.
Okay.
Oh, no, foods min index.
Oh yeah.
Right?
You're right.
And then get name, and then
Yeah.
food. Oh yeah, and we don't need that line.
Okay. Then
And then that's a one-liner,
that's
so we
over,
don't need
you
any of
switch it.
this.
I think we're missing a bracket. Right?
Nope.
No, we aren't.
Nope.
Okay.
So yeah, now we have that, right? So now we have our minimum, and we're gonna swap them. Okay, yeah. Temp equals.
Temp equals min in there.
Wait, what?
Hold on.
Isn't what we need to do to store min index? Store this food at min index, right? We already know.
hold on, so foods.
I think, just a sec. I think, I'm not going to delete that, but I think what we actually need is food temp equals
Yeah.
foods at min index,
Oh, okay.
right? Let me
Yeah.
call it temp food. Temp food. And then what we
Right,
can
right, you don't
do,
need to start this.
yeah, wait, foods X, we don't want that. We want foods, oh no, you're right, sorry. Yeah, temp food.
And then you need to switch min index to whatever was at food X.
Yeah, wait,
And then,
wait. Oh my gosh, wait, do we need that? We need
Or-
a X, sorry.
or temp food.
Yeah, temp food.
Okay.
Okay, so there we have our swapping and that. So that should do the job. Wait, don't we need it to be one less than 3? Because on the last time it won't need to do it. It'll already be there.
Oh, right.
So we can make this 2.
Okay, and then we just need to
Ugh.
print all the advisements just to,
Management. Just a sec. Yeah.
oh, you're right.
Oh, very nice. Okay, we'll get the one back here then. Okay.
Yes, sir.
So what happens is that it'll check the first one, the first food 0, like Jolly Ranchers, and it'll check it with each other 1, right? And then it'll
So
Right.
place
yeah.
it in a temporary spot and put it where it needs to be. How does this work?
Okay, so how it works is that it first finds the index of the next minimum, right?
Okay.
Within the area that hasn't been sorted yet. That's why the X is there, because it starts at 0, and then as we put one in the first slot that is the minimum, then we increase it by 1 so that the space that we're sorting by is smaller, right? And then the one before it is now already the minimum possible. So we know that that's already sorted basically. And then it continues doing that until there's only 1 left, and then it's done. Oh, right, I forgot to say, once it finds that minimum index, the one that has the minimum name, which is the one closest to A,
Okay.
then it swaps it with the first thing.
Okay.
All right, and I'm looking here. I think it worked because banana.
It does
Jolly
look like it
Ranchers
worked.
Salad. That's
Yeah.
alphabetical order.
Let's add some more thingies so that we can be more sure and so that we can have more stuff to work with.
Maybe
Oh, shoot.
I have to go right now.
Oh, you have to go?
Yeah.
Okay, that makes
And
sense, it's 10.
Hiram, in that case, you would have to change the size for that
Oh, you're
X
right.
starts. So we
Yeah.
just do size of the vector.
Yeah, that would probably be a better option anyways. Let's change that so that this is foods.size -1, and this one is foods.size. Ooh, what happened there? Undeclared identifier. What? That's confusing.
Where does it say that? I don't see it.
You don't see any errors?
No, I don't see any errors.
Okay, then it's probably just my REPL acting up. Okay. Then yeah. Okay. And then all we need to do is change this like 3 if we want to add more.
Yeah.
Let's see.
I think it would
Let's-
work.
Let's try to add another one.
I'll do the same.
Okay.
is tomato without
Exactly.
right?
It's a fruit. Okay. That's probably, oh shoot, did I forget to add this on the last one too? I probably did. Just a sec. Yeah. Okay. Nice. Okay, that should be enough stuff. Yeah.
Yeah, and then change to 6.
Very nice. Oh, run into some trouble getting pizza to work.
Yeah, well, it's like what color
Colors
is a
of
pizza,
colors of pizza. I
right?
guess. Yeah, that's hard.
So I put the apple, so hopefully the apple one will come first.
That's a good idea, actually. Very nice. Okay, should we run it? See if it still works. Oh wait, shoot, no. We need to change our see out method.
Uh,
For size ti equals 0, I is less than foods dot size. I plus plus, and then see out foods I dot advisement. And okay. There. Should we run it?
yeah, here, I'll click out, I guess.
Oh no.
Uh-oh.
Oh no.
Um,
Oh. You forgot that it's 7.
oh, it's 7. Oops.
Yeah, okay. Let's see if that worked.
Cool.
Yay. So
All
many
right.
no recommendations. Unsurprising.
Did it
Oh
run
shoot, we need to
multiple
add.
times?
Yeah, it did run. Let's add stuff to our food.cpp as advisement so that we can actually tell what happened. If color equals red and is healthy and is fruit, return an apple and
Or just do
apple a day keeps the doctor away. Okay, does that work?
yeah, I mean,
Oh
yeah, I guess
shoot,
we could probably just have like
I forgot to
name.
use double equals. That was stupid.
Never mind. We can't use that. We can, yeah. Okay. It's another one. A pasta. If none of the statement pasta doesn't apply to any of the statements, kind of.
Yeah, let me make sure that I actually passed that correctly. False, false,
What's the color of pasta?
false. Yellow, I don't know.
You did yellow?
Yeah, why not? Seems right. Color equals yellow and not is fruit vegetable, not is fruit, I guess.
Yeah.
Oh shoot, I don't know what to return for pasta. I'll do tomato then. If color equals red and is wait, I just
Okay.
realized something funny. Oh my gosh. I don't have any advisements for.
Oh, that's what you're gonna return?
Yeah, so that we can tell what it is, even if it doesn't return anything, you know.
Yeah. All right. I don't know what to do for pasta though.
Me neither.
Add I don't know. Linguine.
Some
Pasta linguine.
sauce, you barbarian. don't know.
All right. So,
Wait, that's gonna look awful. Just a sec there. That's better.
all right. So apple, pasta, and then chicken should have, I don't have any
Oh, you're
advisements for
right.
chicken.
Yeah. Okay.
Cool.
See if that works.
All right. I'm clicking run.
Let's go. Don't have any advisements for apple.
Apple.
Is healthy, not vegetable. Is fruit.
Okay.
Is healthy, is fruit, color is red. Did you put color red? Oh, you put color as Y.
Oh, wait. Where is that?
In the
forget.
main, I changed it.
Okay.
Okay, let's see if it works.
So,
An apple a day keeps the doctor away. Don't have any
Uh-oh.
advisements for banana. Don't have any advisements for chicken. Jolly Ranchers are pasta. Add some sauce. Salads are very, very good for you. And a tomato a day keeps the doctor away. Perfect. That's the funny thing that I thought would happen.
all right.
Okay, that's probably good.
Oh, a tomato a day keeps the doctor away because it's
they're both
healthy,
red
red,
fruit.
and they're fruit. Okay. That's funny.
Okay.
And so it does it twice though.
Oh yeah, that's because we had something outing it before from the linked list.
Oh. Okay, yeah.
So yeah,
All right.
that's not a problem.
So,
However, where is blue coming from? Oh, we're still see outing the color of the. Oops, that was from a test. Let's see out instead.
just like a bunch of dashed lines.
Yeah, that's good. Wait, underscores are nicer. Okay, that's good enough. Wait, I almost forgot. Okay, let's see how what that does. Yeah.
All right. So,
Okay, that's good.
okay, so we have apple first, then banana, then chicken.
A B C
Yep.
D E F G H I
ABC.
J K L M N O P Q R S T. Okay, perfect.
Yep.
Sorted.
All right. Awesome. So, okay.
Wait, now we can do our binary search. Yeah,
Okay, sure.
let's do that really quick, and then we can probably finish.
So the binary search.
Oh yeah, do you know how to do it?
It works like so now that it's ordered, it goes from like a straight line from like the bottom to the top.
That's linear search.
Yes. Oh, binary search. Are we supposed to be doing binary search? Because I think that's, it's not B, the 2B class.
Didn't we had to do it for multiple quests so far, so I'm
Okay.
gonna say yes, we have to know how to do it.
All right.
Binary sort, I think, is 2B, but binary search, I think we should do. Okay. You know how it works, or?
Yes, I'm looking at it right now.
Okay, got it.
So um um So if we
Wait,
did it
what?
like this, we'd have to also make it in the
I don't think we want to do it like this because we're searching through a vector, which isn't something innate to the food class.
okay.
So I would just make it out here. We don't need to make it a method or anything. Although we probably would want to normally make this methods, but whatever. An entirely different class, like a, yeah. I like using a while loop for this.
So let's see. All right. So all right, you're gonna have to help me on this.
Okay. More than
So I see that you have to you compare it with the middle term.
Okay, let me just see if I can set up the way I like to do this. So what I like to do, I don't know if this is exactly what you're supposed to do, but what I first do is just check if foods, oh my gosh. So actually, I set up quite a few variables first. So what I do is int left bound equals 0 and int right bound equals foods dot size -1. So the
Okay.
reason that it's -1 is that it's an index, because it's an index, right? So we don't want it to be the actual size.
Okay.
And then we say if left foods left bound equals, oh, how stupid, equals wait, what are we searching for?
Yeah, it's kind of hard when you don't have like you
Are
search
we searching?
you don't input like something that you're searching for. So should we just
Hmm.
say, oh, we're gonna search for banana out of all of this?
So let's just search by name, right?
Okay.
Get name is equal to, let's call it target just because, and then let's make a variable up here because I don't want to write out everything every time. String target equals banana. Okay. If the foods is the target, right, then return left bound for the index, right? Well,
Okay.
actually, that's not what we're doing, right? We need to
Return target.
we need to just skip the rest, huh? I'm trying to figure out how to do this because usually I do this in a method, right? But we can't really do that in a method
Mhm.
out here. Ah, that's annoying. Or rather,
We could make it a method.
we
but
could do
just,
it a method, but just make it out here and not like a special
Mhm.
method or anything. So let's do it out here, up on the top or something. Or can we do it on the bottom? Can we?
I think we can.
Probably. I think I've seen it done.
Yeah, you can do it at
Okay.
the bottom.
Okay, so then we can say, what are we? We're searching for an index, right? So we can say int. I don't like using size t, although I probably should for this. Int binary search by name or something.
Yeah.
Okay. String target. Okay. Yeah. Okay.
Then
And then let's copy this part
yeah.
and say. So now we have our left bound and our, oh shoot, we need to give it something to search through, huh? Let's call it vector of food, and it needs to be a reference, huh? So we're gonna do and foods, yeah. There. Okay. Return left bound, right? And then if foods right bound dot get name equals target return right bound. Now this, the reason I like doing this is because even if it's a little longer in terms of like code, it just quickly stops if it sees it.
Uh-huh.
So I don't have to do any calculation at all except that. And on top of that, it makes the rest of it a lot easier for me. So what I do after that is say while, and then oh, right, we need one more thing. Int mid, let's call it median, right? Equals left bound plus, oh, oops. Left bound plus right bound
Divided by
divided by 2.
yeah.
Oh my gosh. Now the reason that we can just do that and not worry about like if it's going to be 0.5 is because int just is int. So it'll give us the floor, which is great. Okay, while median, so then this condition is a bit, I forgot that I can just have this later. While our check is that we want to make sure that left bound is less than right bound minus 1. Now, the reason for that is because what we want to do is while there's something in between the left bound and the right bound, right?
Mm-hmm.
We want to continue checking to see if the thing in between it or
Is
the
well,
median
our target?
is our target. Yeah.
Okay.
So that's our condition. And then inside that, what we're going to do is set up our median, right? And then we're going to do a lot of comparisons. If foods median dot get name is equal to target, right? Then we're going to just return median. If foods median dot get name is less than target, then what we're going to do, if it's less than, so the median is less than the target, then what we're going to do is say median. We're actually going to say the left bound.
Yeah, the left bound
equal
is
to
going to
the
be the
median.
median.
Yeah.
Oh, I get it. Okay.
And then,
And then you
well,
check left
I should
bound
probably
to
say else
right
if
bound.
there, right?
Yeah.
Else if foods. Now, I don't really have to do this, and it would probably be better not to, but sometimes I like to just so that it looks nicer.
And then you can do the right bound and then median.
Yeah. Else right bound equals median. Yep. And there you are. I think that's it. I don't know if this will have any errors because I have made a few errors while doing this kind of thing. But yeah, and then if none of that happens, return
false.
We can't say return false, it's return an int. So let's say -1.
Okay.
For not in the array, right?
Yeah.
Because that can't be an index. Okay. There's our method.
I see it. Okay.
Now let's see if it works. Moment of truth.
It won't count anything though. I don't think. Just
int target index equals. Yeah, it won't see out anything, and I'm doing that on purpose. Oh,
yeah.
Actually, yeah. Let's just do that. Let's do that. We're gonna have to do something weird. Foods binary search by name. Target, target.
Target. Just target.
Yeah, target, target. And then we also need to put in foods as the
So-
referenced vector, right?
Yeah. It's a reference vector.
And okay, what does it not like? Okay, maybe it doesn't like us using it below, huh?
Yeah. Well, I don't. I think it should be fine below. I thought.
I'm just gonna not and put it up here. Fix it.
Has not fixed it.
Oh gosh.
It's binary expression. Oh, I think it might want capital foods.
I don't think so. It
No.
wants a reference to a vector of food. I'm gonna reload. Just a sec.
Yeah, I might click the button.
Does it still hate it? It still hates it. Why?
Yeah. Okay.
Operands to binary expression.
Let's just run it. See what it says.
True. Complain,
Okay.
complain, please.
Oh, big complaint.
Interesting. Oh, it doesn't like us see outing a food object. That should have been really obvious. Okay. We want food. Wait, no. Wait. Oh, wait. We just want to see out the index of banana.
So I think we should just say
Let's
in
try
our
this.
binary search, should we have it return what position it is in the vector?
That's what it's doing. I
Okay.
just missed. I just messed up and we want it to do this. Let me see if it works now. Banana is at index 1. Perfect. It worked.
Okay. Cool.
Well, I didn't actually make it say that. I just seated the thing. Let's see. Target plus is at index plus, oh my gosh, plus 2 string binary search foods. Okay, see if that works.
Did we?
Yeah.
Bananas.
I
Bananas.
messed up and didn't put in a space. Okay. There we are. Banana is at index 1. Okay, we should go. It's 10:30.
Yeah. All right.
Bye.
Bye bye.